Now let us see the applications of Heron's formula in finding areas of quadrilaterals. Our first question, that is our example number 4 of this chapter, is Kamla has a triangular field with sides 240 meter, 200 meter and 360 meter. Now I'll just draw a field like this. So this is a triangular field. One of the sides is 240 meter, another side is 200 meter, and the another side is 360 meter. Then where she grew wheat, where wheat is grown. The next is another triangular field of sides 240 meter, 320 meter and 400 meter. Adjacent to the previous field, she wanted to grow potatoes and onion. So adjacent to this field, let us draw another field. One of the side is same, so the side that is same is of 240 meters. So we just draw the triangle here, adjacent to 240 meter. So it is 240 meter. Then another side is 400 meter and another is 320 meter. Now she wanted to grow potatoes and onion here, and so she divided the fields into two equal halves. That is, this would be 200, this would be 200. Two equal parts, and this line is divided into two, and then in one part she'll grow potatoes and in the other she'll grow onions. Now how much area has been used for growing wheat, potatoes and onions? In hectares it is asking, so hectare is given as 10,000 meters square. So first we'll find out the area of each triangle and then we'll convert it into hectare. Now let us see the diagram, the more formal diagram as I have drawn in a more clear way. So here we can easily find out the area of triangle ABC. First, let me write down the triangle in which different crops are grown. So in triangle ABC, the grown crop is wheat. Then in triangle, these two triangles are for potatoes and onions. So in one of the triangle, I consider AEC, onion is grown, and in another DEC, potatoes are grown. Potatoes are grown. So now we can see that now we know we can easily find out the area of A, B, C. It will be S minus A, S minus B, S minus C. Now let us consider our S. S would be 240 plus 200 plus 360 divided by 2, which is coming out to be 800 divided by 2, which is 400 meter. Our S is 400, so let us put it over here. 400 minus 360, then 400 minus 240, then 400 minus 200. Once we'll do this, we'll get our answer at this to be 400 into 400 minus 360 is 40. Then this would come out to be 160, and 400 minus 200 is 200. So first let us take out the zeros. So first pair, then this is second pair, then this is third pair. So we have a 10 into 10 into 10 outside the under root. So we have 4 into 16 into 2. So now we can easily see that this is forming a pair and this is a perfect square. So what we'll get outside is 4 into 4 into 1000 under root 2. So our answer, that is our area of triangle ABC, is coming out to be 16000 under root 2. And to convert it into hectare, 1 hectare meter square, and 1 hectare is 10 1000 meters square. So we'll just divide it by 1, 0, 0, 0, 0. 4 zeros. So 3 zeros are cut and then we'll get our answer to be 1.6 root 2 hectare. This would be our answer, first answer. So I'll just write it over here. The area of triangle, area of wheat grown triangle is, that is ABC, is coming out to be 1.6 root 2 hectare. Now let us move on to find out the area of the triangles or of the triangular fields on which onion and potatoes are grown. But here there is a problem that we do not know AC, EC, as our triangle on which onion is grown is AEC, but we do not know EC. Now what we can do is let us analyze the triangles further. Now seeing in these triangles, we observe that the base of each of the two triangles is 200 and 200. Now if we'll draw a height, if I'll draw a height over here, that is this should be 190 degree, and if I draw a height, let us assume this is our height. So we see that height is also same for both the triangles. Let me draw it here. If my AEC, this is 200, this is my height, right? So this is my height for AE, AC, E. Then for the triangle, this triangle, that is our CDE, we also are getting the same height, that is this. We know that we can draw our height like this, right? So from vertex C, this would be our height, and the base is, we do not consider our base to be this, but we consider our base to be this side, this only, that is ED only. So it will be 200 meter. So now we see that both of the triangles, base and height, are equal. Now area is given as half into base into height. Since base is equal, height is equal, their area will also be equal. So now all we have to do is we can easily combine their area, and we can easily find their area as their area is equal. So all that's left to do is let us find the area of ADC. Since we know that these two triangles are equal, so area of triangle A, B and C is equal to area of triangle AEC plus area of triangle E, B and C, right? So now since these two triangles are equal, so area of triangle ADC can be written as 2 into area of triangle AEC. As we draw triangles. Now, hence we can easily find out the area of ADC since all the sides are known to us, and then divide by 2 to get our area of AEC. So let us do that. Now first let us find out the semi-perimeter, which will be 400, since this side is 400, plus 240 plus 320. Let us divide by 2. So once when we will divide by 2, we'll get the answer to be 960 by 2, which is 480 meters. So our semi-perimeter is coming up to be 480 meters. Now let's directly apply Heron's formula and find out the area of the triangle. So A is equal to under root S minus A, S minus B, and S minus C. So area is equal to 480 minus A, which is 400, 480 minus B, which is 320, and 480 minus C, which is 240. So our area is coming out to be 480 into 80 into, let us subtract 480 from 320. So we'll get 160, and then 480 minus 240 is 240. Let us take out the zeros first. 0 and 0. So these two have two pairs are left. So 10 into 10 under root 480 into 8 into 16 into 24. Now let us divide these into the multiplication or the factors of perfect square and prime number. 10 into 10 under root 48 can be written as 16 into 3. 8 can be written as 4, which is a perfect square, into 2, which is a prime number, then 16 is a perfect square, and then 24 can be written as 4 into 3 into 2. Now, let us take the numbers out. We can see 16 into 16. So, we'll take out 16 into 100. And then we can see that there is 4 and 4. So, we'll take out another 4. Then we can see that there is 3 and 3. So, we'll take out 3. And there is 2 and 2. We'll take out 2. And nothing is left except 1. And 1's under root is 1. So once we multiply all these numbers, we'll get our answer to be 38400 meters squared. Now this is meter, we have to find out the area into hectares. So all that's left to do is to divide it by 1, 0, 0, 0, 4 zeros. So once we divide, this 2 is gone, and then we'll get our answer to be 3.84 hectare. So this would be the total area of this triangle. Now to find out the area of AC on which onion is grown, all that's left is 8.3484 divided by 2, which will give our answer to be 1.92. And similarly, because these two areas are equal, so this also, the area on which potatoes are grown is also 1.92 hectare square. Hectare, not square but just hectare. So we'll just write our answer over here. Area on which onion is grown is coming out to be 1.92 hectare. And similarly, area on which potato are grown is coming out to be 1.92 hectare. And this is how we solve our problem. Now let us see another application of using Heron's formula. So in this question, the students of a school staged a rally for cleanliness campaign. So they are having a rally, and they walked in the rally through lanes in two groups. One group is walking around the lane A, B, B, C and C, D. So let us see what A, B, B, C and C are. So one group is moving around A, B and B, C and A, C. So we are getting this triangle, right? Now, while other is moving through AC, CD and DA. Now let us see what our AC, CD and DA are. So in this question, we have our AC as this, and we have our CD as this, and AD as this. So these are the two triangles on which the two groups of the students are walking. So what we have to find out is, we have to find out which group cleaned more area. That is, on the lines on which they walk, they have cleaned the area inside them. So which group cleaned more area and by how much? And we also have to find out the total area cleaned by students. So first it is given that our angle B is 90 degrees. So this angle is 90 degrees as it is shown here. So we want to find out these two areas, and that's it. And we have to find out that by how much area the other group has cleaned more. So the first step is to find out the area of each triangle. Now here we can easily find out the area of ABC since it is given as to be 90 degrees. So we can easily apply our formula, half into base into height. So when we apply it, it will be half into, what is our base? It is 40 meter into height, which is 9. So we'll get our area to be This is B20, so we'll get our area to be 80 meters square. Let us write down over here. Area of triangle ABC, which is coming out to be 180 meter square. Now let us move on to our next triangle. Here we can easily find out the area by Heron's formula, but the problem here lies is that AC is not given to us. So we'll have to find out AC. And we can find out AC by using the triangle ABC by using Pythagoras theorem. Since it is making 90 over here, so we'll just apply Pythagoras theorem to find it. So to apply Pythagoras theorem, we know AC square will be equal to AB square plus BC square, right? So our AC square is what we have to find out. AB is given as 9. So 9 square plus BC is given as 40 square. So we'll just write 81 plus 1600, which will come out to be 1681. This is our AC square. Now let us take the square root. 1681. This is the square root of our number 41. So AC is coming out to be 41. Now let us now we have all the three sides, so let us find out the area by using Heron's formula. So first the first step is to find out the semi-perimeter. The semi-perimeter is given as AB plus BC plus AC divided by 2. That is sum of all sides divided by 2. So our AB is 28 plus DC is 15 plus AC is 41, and let us divide it by 2. 41 plus 15 is 6, and we'll do is 56. So 28 plus 56 divided by 2, which will come out to be 42 meter. So this is our semi-perimeter. Now let us apply our semi-perimeter in Heron's formula. Our semi-perimeter is 42 meter. So let us apply under root S, S minus A, S minus B, and S minus C. So our S is 42, 42 minus 28, and 42 minus 15, and then we have 42 minus 41 under root. Now let us do that. 42 can be written, first let us just put all the numbers. So when we subtract 42 minus 28, we get 14, then we have 27, and then we'll have 42 minus 41, that is 1. So let us convert all these into prime numbers and perfect squares. So 42 can be written as 7 into 6, which is 3 into 2, right? And 14 can be written as 7 into 2, and 27 can be written as 9 into 3. So let us pair things up. 7 into 7, we can write 7 over here. Then we have 3, 3, we can write 3, then 2, 2, 2, and then another 3 because of 9. Now nothing is left, only 1 is left. So under root of 1 is 1. So our answer is 7 into 3 into 2 into 3, which will give us our answer as 126 meters square. So we see that area of triangle ADC, that is the area covered by group 2, is 126 meters square. Now we can easily see that group 1 has done more work by covering the area 180 meters square, and by how much is 180 minus 126, which is 4 and 5, 54 meters square. So this would be our answer for this question.